Right, yesterday we started this securing our network right from layer 2 level. We learned that attacks are possible when unlimited MAC address learning on ports. To control that, we learned that we should enable port security. We also did an exercise on port security. Right, some show commands are listed here. The next topic is .1x. To use .1x as a security feature, we need to know about this AAA. What is AAA? AAA is authentication, authorization, and accounting. Authentication means, who they say they are is authentication. Authorization means what? Using the permissions, what all tasks can be done, or what all tasks the user can perform once he is authenticated. That is what we call it as authorization. What all he can do after entering into the switch. That's authorization. Lastly, accounting. Accounting is what all he has done. See, what all he can do is authorization. What all he has done with the permissions that he has got, what all he has done already, how much he has done, what all he has done. That is what called as accounting. See, for example, in an organization, when you log into a router, you will find some commands which you only can use, others cannot use. Same router, when others join, when others log in, they cannot use because they are not authorized to put those commands. Say, for example, you take care of security, securing layer 2 network. That's your job. So all the port security commands will be available for you when you log in. But when another employee logs in, he don't have those commands. Same switch. Same switch. Don't provide those commands. Put question mark, you won't find the commands. Means your neighbor don't see those commands because he's not a layer 2 security engineer. But you have some commands which he don't have, and he has got some commands which you don't have. His role provides him different sets of commands to configure. Your role provides a different set of commands to configure. Depending on the role, the command varies. How is that possible? Authorization. We call that as command authorization. To your user name, the command authorization is binded. For example, when user Santosh logs in, he's a layer 2 security engineer. When he logs in, the authorization allows all security related commands for him to use. Now, Santosh is a layer 2 security engineer, but Anand is not a security engineer, but he is a routing engineer. So he takes care of routing. Even on the switches, he has to check whether the VLANs are proper so that the packets can be routed, whether trunks are properly configured. So when Anand logs in, he has got commands like VLAN, name, you know, switch port mode access, switch port mode trunk. Because for Anand, those commands are binded to a username. So depending on the user, authorization varies. And accounting is keeping track of what has been done with the permission that Anand and Santosh have got. Santosh have got all security related commands, but which command he used today? With that command, what he configured? All those things are what called as accounting. Accounting is nothing but auditing, monitoring. And billing is also another term. Okay, now to do these three things, you can use Radius or TACAX Plus. Radius is industry standard AAA server. TACAX Plus is Cisco proprietary AAA server. Radius uses UDP. TACAX uses TCP. Right? Radius is industry standard. Radius you can run on a Dell server or any server, but TACAX Plus you need to buy Cisco server, Cisco's AAA server. TACAX Plus is Cisco's TCP based protocol. TACAX does three level authentication, authorization, and accounting. Whereas Radius does authentication and authorization accounting together. Radius, only two steps. TACAX, AAA, three separate A's. Radius, as soon as someone is authenticated, authorization and accounting starts. A and AA. But you remember in CCNA, we authenticated by creating username and password in the global configuration mode, isn't it? The global configuration mode, we said username, Santosh, password, 123. So what is the difference between that and this? That is local authentication. This is centralized authentication. You see, instead of going and creating all users one by one in every switch and routers and computers, instead of creating on every single device, we have all the usernames and the permissions for the users written here. Those policies are written here using this radius and TACAX. So that has got the complete database of users and the roles According to the role, authorization, everything is configured in these boxes. So you don't need to go to every single switch to configure this. You don't need to go to routers and switches and every network device to put the usernames and passwords. We have everything centralized. So if someone turns off this, no one will be able to log in. Because what happens when someone tries to log in, the switch is configured by us to go to radius. If radius is reachable, radius will provide challenge. Radius will ask for username and password. Now the user is typing the username and password. That is also forwarded to the Radius server. Radius server checks in the database for the username and password. When there is a match, whatever the user is allowed to type, those authorization, everything is pushed down and the user is allowed inside. If in case the username and password doesn't match, then it will not approve. It won't allow the illegal entry. Now let us say this radius wire is disconnected. That is why you have another one. So in this route, in the switch, you have radius 1 address R1, radius 2 address R2. R1, R2 is IP address. And then TACAX 1, that's the third server, T1. TACAX 2, that is the fourth server. So we put the IP address of all these devices so that it will check first server. If the server is unreachable, it will check the second server. If that responds by saying deny, it won't check third server. It will not check the third server. Why? There is a server saying deny this guy. So it will be denied. That's it. It won't go to the third server. Then when will the third server be used? Only if second server is unreachable. When a server is reachable and when a server denies, it won't go to the third one. If in case these two wires are disconnected, cut, after checking, it comes to know that I'm unable to reach these IP addresses from the switch. Then it will go to the IP address of the third server. And this guy will say, okay, get the username and password. And this fellow types the username and password. This checks, and Tech Express don't see the username matching. What it will do, it will say deny. Don't allow him. That's all. Switch will deny. It will not go to the fourth server. So what do you understand from this? You can have multiple AAA servers for high availability, for redundancy. If one is unreachable, the next one. Now, what if all or off means someone has cut this wire here? Will this guy log in? He will not if you don't add fifth method as local. I repeat, method 1, check R1 radius. Method 2, R2 radius. Method 3, method 4, tech X. If all these are unreachable, then you can use the local database. So you can say locally also username, Santosh, password, confidential. So this username and password you will not give to any engineer. That is only for recovery. One person only will know. Not all engineers will know. All engineers will know the username and password which is stored in Radius and TechX. But the topmost guy will also have another username and password which is not here in this database. Only during the disaster, he will use that username and password which will be locally authenticated. That's method 5. But to use method 5, the first 4 methods should be unreachable. Yeah. So we saw example radius, TechX, local database. You also know line password we used to do the CCNA. You also know enable password. We also log into a router with no authentication initially, right? This is also an old Microsoft authentication algorithm. We don't have this for Cisco routers, but old and Cisco routers were supported. This is very old. We don't have right now. Right. So as I said, you have an authentication server. Wait, this topic is over. This AAA, what does AAA means and how AAA works is over. Now this is another topic similar to that. We have a protocol called IEEE 2.1x. We used to call this as .1x protocol. .1x protocol is port-based authentication. This is device-based authentication. This is port-based authentication. So we have clients here. Request access and response to request from switch. So this guy is requesting an access. If switch will show a challenge, it will respond. That's client's job. Controls physical access to the network based on the client's authentication status. Yes. Now, in this switch, what you have enabled is a .1x. So when a client is trying to access this box, or it can be an internal computer, whatever, is coming through this port. If he's coming through the port where .1x is enabled, the switch will interfere. Switch will say, hey, stop. Stop. I want to authenticate you before I allow you. And then when this guy gives the right username and password, it may check the local database or it can use the external authentication server, which you learned in the previous topic. And if this guy gives the green signal, then .1x will permit. But this lab you cannot do. The reason is .1x is not only on Cisco switch. On Cisco switch you configure, but to use .1x service you need a client software. .1x client software. With the client software only you can contact the switch. Put the username and password. So you see here only what to be configured on the switch side. In the next page, it will show only the commands that you configure on the switch side. But that is not enough. You also need a special software to install on the client, so that using that software only, you go and request for an access and provide the username and password using the software. And that username and password will go and check, and then if it is allowed, then traffic will pass through. All right, you need to depend on the third-party tool for this. Okay, now this is the configuration for .1x, and this is the configuration for Radius or TechX. For Radius or TechX, we say AAA authentication login method 1 means Radius. Instead of method 2, you say TechX plus. Method 3, local database, something like that. I'm going to do and show you now. Before that, let's finish this .1x. We don't have lab for this. Only the switch side configuration is shown here, as I told you. A switch side configuration alone is not enough to check .1x. You also need .1x client software. Now this enables the AAA service. This is the very first command we will do for both the lab, even the previous lab, Radius TechX lab. This is enabling AAA service on the switch. And then you have to say AAA authentication using what? Here, this is about .1x. So you say .1x. The default means for all logins. Console, telnet, SSH. That's what default means. And then what method would you like to use? TechX? And if TechX is unreachable, you want to use Radius. So on. All right. So that creates a .1x port-based authentication method list. Now, to enable globally this port-based authentication .1x, this is the command. .1x system auth control. And then go under the interface as I specified. This is interface level authentication. This is to enable the service, and this is to say on this particular service F0/1, I want .1x to be in control to authenticate. All right. Now I'm going to do this AAA lab for you. In the PC key, if we have given IP address to this PC, you see. Likewise, I'm going to give IP address to this PC. And for the server also, we need an IP address. I'm going to give 10.0.0.100/8. And on this PC, sorry, on this switch, let's start from this switch. This switch needs an IP address. Where will you give IP address to a switch if you want to manage a switch? For example, you want to telnet a switch and you want authentication. Where will you put IP address on a switch? Switch is a layer 2 device, but when you type this command and see show running, you can see a layer 3 interface called interface VLAN. You can put an IP address here. That will become a management IP address for VLAN 1. Host name switch 1. interface VLAN, because all the physical interfaces are right now member of VLAN 1. When you give an IP address to interface VLAN, all interface can access this IP. I'm giving 10.0.0, sorry, VLAN 1. IP address is 10.0.0.3 as per the plan. All right. Okay. Now you can ping those two PCs from here. 10.0.0.1. Show IP interface brief. Oh, it is administratively done. See, we have to say no shutdown. Okay, ping now. 10.0.0.1, you will be able to ping. 10.0.0.2, you will be able to ping. Okay. Next, on this switch, we are going to do similar configuration. Switch name is 2. Interface VLAN 1, no shutdown. IP address is 10.0.0.5. Now, from this switch, you can ping the other switch and two PCs. 10.0.0.1, you can ping. You can ping 10.0.0.2. You can also ping this 10.0.0.3. You're pinging from one switch to the other switch. See, we're able to ping it. Okay. Likewise, let's go to router and give IP address. What is the interface name? G000. Four. And now I can ping from here also to those PCs and switches. It will ping. It will take some time, but it will ping. The reason is the link should come up. It has come up now, and ARP and all. Now you see it will ping now. See. Also, it will ping 10.2, 10.3, which is another switch, and 10.5 is another switch. Okay, so I'm able to ping between these devices. Now let's go to the server. On server, I say 10.0.0.100. And from server, I am expecting ping 10.0.0.1, 2, 3, another switch is 5, and then the router is 4. Okay, we got the basic reachability. Now, if anyone tries to log into this three network device, our aim is to authenticate and then allow. For that, we are planning to use Radius and TechX. You can enable Radius and TechX on same server. That's why I did not take two separate servers. But in the real world, they will have two separate servers because if in case one goes down, there will be another server. They'll keep TACACS in one server, radius in another server. But I don't want to make it more complicated. You can try those things at home, but I'm going to do both TACAC and radius in this. And I'll tell the switches and routers that first you check TACAC. If TACAC is unreachable, then you check same address for radius. Yeah, same address for radius. And that's the plan. Now, I'm going to TACAC. You see, you go to services and you see AAA, and then I turn on, and then it is radius. See, radius and TACACS. I have radius, and this is for switch 1. This switch 1. Switch 1. Switch 1's IP address is 10.0.0.3, correct? And we have to give a pre-shared key, meaning the switch first of all should authenticate the server. You see, you want to protect your house from the thief. So you buy a lock. Will you buy a lock which is 15 rupees to protect one big house? Will you buy a lock which is 15 rupees, that small one, to protect your big house? No. How will you buy a lock? Anyone say? This is a common question, right? How will you protect your house? It's a new house. You want to put a lock to your door. What will you do? யாருக்கும் வீடு கட்டுற ஐடியாவே இல்லை போல. நல்லா காத்ரேஜ் பூட்டா பார்த்து வாங்குவீங்க. ஏன்னா காத்ரேஜுங்கிற கம்பெனி வந்து ரொம்ப வருஷமா இருக்குது. ஃபர்ஸ்ட் அதை நம்புவீங்க. அந்த கம்பெனியை நம்புறதுனால அந்த பூட்டை வாங்குறீங்க. If you don't trust that lock vendor, you won't buy the lock. என் வீடு திறந்தே இருக்கட்டும் பரவாயில்லன்றீங்க. பூட்டு கம்பெனிக்காரன திருடனா இருந்தா என்ன பண்றது? வேணாம், பூட்டே வேணாம், திறந்தே இருக்கட்டும். So what I'm trying to say is this and these devices, they need to first of all trust each other. For that, you need to put one password, because tomorrow someone will bring their TACAC server and Redis server with their username and password and connect to the switch. What will happen? Danger. Switch will allow. So switch won't allow any TACACs and radius. Switch will allow only if IP address is this and password is ABCLKG. I added. This is radius server. All the switches should come, and all the switches and routers should come and authenticate first with this guy. Before authenticating these two fellows, these devices should find out the genuine server by authenticating. That's why we put this password. And next, there is another another switch with 5 address, same key. And router is 4 address. Router is 4 address with same key. Next, what if the TACAC server fails? I also want radius. Sorry, what if radius fails? I also want TACAC. And I would like to have the same key. If you want, you can have different key. Again, for the next device, and for another device, oh no, I made a mistake. This is 4 is router. What is the name I gave you? RA. Router TechX. Add. So this is correct host name, but 10005 is switch underscore 2. I can edit. Switch underscore 2. And 10003, this is correct. This again, RA. Okay. Done. See, so far what you have done is you have told this TechX and Radius server who are all clients. These three are clients. These PCs are not clients. These PCs are users. For TechX and Radius, these three devices are clients. So 3 devices, they need both TechX and Radius on the same device, and A, B, C, D. Now, what about the users? To access this 3 device, if someone wants to come, means if this users wants to access, they should come with username Santosh, password Anand. Another user, user2, password user2. Likewise, you can have many users. Done, finish. On the server side, I've finished. Now going to the, let me start from the router. I'm going to say AAA new model. This is to enable AAA. AAA authentication. Login. Method. Okay, give a name. I will say a name as A underscore. It's a name, that's why I'm writing like this. Don't think like a command. And then method 1. Method is told by putting this group command. Group. Method 1, I want TechX. First check TechX. If TechX is unreachable, then you check radius. Okay, group again, radius. If that is also unreachable, then you go with local. You see, local, group, local. Sorry, simply type local. That's it. Next is, I need to tell where this TechX and radius exist. Where it is. It is in 10.0.0.100. So I'll say like this: IP AAA server TechX server. What is the IP address? 10.0.0.100. And what is the key? You remember the key that we gave there, pre-shared key, ABC LKJ. ABC LKJ. That's it. And where is the radius server? Radius, there is no hyphen. Radius server. Host. No. Name of the radius server configuration. Let's say red. Okay. Here, syntax is slightly different. Address. What is the address of radius server? Same, 10.0.0.100. For us, it is same device. Address IPv4. Okay, follow the syntax. 10.0.0.100. And key, same. What key? ABCLKJ. Am I right? Radius ABCLKJ. Right. Done. Warning. Command has been added to the configuration using the type 0. However, type 0 password will soon be. Okay, that's not our business. Exit. Next is I need to go under line VTY 0 to 4 and tell line VTY to use AAA. Okay, so this is the command. Login authentication. What is the word we gave there? I said A underscore A underscore A. You remember the method when we design, when we say method, we put this is the name. All right. Login authentication A underscore A underscore A. Enter. We said use this AAA. Whatever is said as a method, first you go to TechX. That's what we have said there. We are calling those things down. First you go to TechX. If TechX is unreachable, then go to radius. If radius is also unreachable, then check local. Okay, now local. For local, I'm saying username 123, password 123. I can also use Santosh and Anand here. I'm just using different one. That is all. We have finished. We are finished. You're going to do the same configuration on the other switches. Because of time, I'm not going to do all this switch. Now I'm going to show you here. Telnet 10.0.0.4, the router's address. See, it is asking username. And I'm going to give Santosh. What spelling I gave? SANTHOSH, or I can also use user to user to. Let me say user to user to. User to user to. So it's allowing me inside. You know very well that local I did not give username as user to. Local what name I have given? 123 123. So this itself proves that you are being authenticated using what? Using TechX. Now let me go to this computer and say telnet 10.0.0.4 again, and I'm going to give Santosh SANTHOSH Anand ANAND. Oh, I think spelling mistake. SANTHOSH NAND SANTHOSH. ANAND. Okay, I'm inside. So using TechX, these two guys are logged in, not using the local database. Show users. You see, you can see user 2 and Santosh is logged in. Yeah. I don't know whether I can see the users here. If it is a real TechX server, we can see the users. No, this is not showing the people currently using the service. Okay. Now, let us do one thing. We will shut down this. I am offing the server. See, it's offed. You can also see it is red in color. Now, I will exit from here. You know very well that TechX and Radius cannot be reached now. So now I am going to say telnet again, and then I'm saying user 2, user 2. It won't allow. It will take some time and come out, meaning it is searching. It is searching for TechX and Radius. First it checks TechX and timeout happens, and then checks Radius and then timeout happens. And then it will check for local, but local username is not this. So it will come out. It won't allow you inside. It has to, you have to wait till it times out. It has to check 3 methods, no? Local method also, we don't have this username, so it will come out. Meanwhile, I'll go to the other computer and do the same telnet, but this time I will use the username. What is the username we have local? Anyone remembers? 123, 123. 123, 123. This will also take some time, but it will go in. Why it takes time? It checks the TechX, times out, checks the radius, times out, and then goes in. That's why this delay. It should not take this long. Here you see it expired, but you won't get that information in the next one. This will go in. You see, you are inside now. It took some time because it has to verify first 2 methods to go to the third method. Did you all understand? Was it interesting?